And happy Sunday. This is PFG Live. And welcome aboard. My name is Spencer Webb. I'm in southern New Hampshire, and where the current temperature is 85 degrees and 47% relative humidity. Welcome to Evils, who is here from Belgium, reporting all sorts of things. 29 degrees and a 46% relative humidity. Dale is here from Edmonton, Alberta. I'm sorry, Edmonton. Yeah. 24 degrees, partly cloudy, and for once, no smoke today. There were a lot of wildfires out in Western Canada and causing some real issues in Alberta. Tuck is here from Buffalo, 90 degrees Fahrenheit and sunny. Very low humidity. Josh gives us an audio check of check. Who else do we have? In the YouTubes, Carl Tauber from the People's Republic of Rhode Island is here at 77 degrees and sunny in Rhode Island with a dew point of 64. Robin is here reporting sunny and comfortable. Thank you, Robin. Welcome aboard. Stephen is here. He reports cloudy with the chance of 2-year-old coolant. About 95 in the shop, but a nice 84 outside, 71% humidity. Welcome aboard. And Stephen is relatively new to the Discord. Nice to see you. Pixel is here. So he's reporting from KSAT. Winds are 120 at 9 knots, visibility 10 miles. Sky is broken at 900, overcast at 20,000, temperature 27, dew point 25, altimeter 3003. Remarks, rain ended at 1652. That's exciting. Shaden HKW reports 79 and dry. Welcome aboard, sir. Nice to see your face. Well, your very, very small face, but you're here. That's what's important. So we have a very exciting day planned for you guys, and I only can remember what it was. Oh yeah, we have we have our good friend James Clough here today, and we're going to be talking about everything. And we have a very detailed, well-planned, carefully balanced. I have no idea what I'm talking about. We're going to be completely random and enjoy his company. So without further ado, let's just bring him in. So James, welcome aboard on PFG Live. Nice to see you.
Hey, good afternoon.
And if the rumors...
Yeah, it's afternoon here too. Yeah.
We have a saying here, it's afternoon somewhere. So that's totally normal. I can't tell you how many times I open the show with good morning, and it's 2 o'clock here. It's like, it's not morning. Nobody ever complained. So you're in Boise, Idaho, right? Boise?
Close to it, yep.
Close to it. And I was corrected. A friend of my kiddo is from Boise. And, of course, I said, oh, nice to meet somebody from Boise, which is how us Easterners say it. And I was schooled. So is that a major thing to make sure people from Boise?
Some people care more than other people. You know, it's Boise. But, you know, if you were to say Boise, I probably wouldn't say anything.
That's because you're a nice guy.
Just, you know, be here content in the knowledge that you don't know what you're talking about.
Excellent.
But, you know, I'll just use that information. I won't rebuke you.
Excellent. Thank you. I did notice you put my name in a notebook, which had me a little nervous. So we know you from YouTube. You have a magnificent YouTube channel, Clough 42.
Oh, well, thank you.
And everybody knows what the 42 stands for, so we don't have to dwell on it. Hey, Test Room just checked in from Oostkapelle, Netherlands, with 21 degrees science, 57% relative humidity. This guy named Clough 42 just checked in at 81 and dry-ish in the Boise. PM 2.5 is... Okay, what does that mean? PM?
Air quality.
Oh,
particulates.
Do you count them?
Yep.
One at a time?
I don't. I just use the service that tells me.
Believe it or not, Evils recognized that you gave a dust report or a, Concord.
It's smoke.
It's smoke. Almost Machining is here from Arizona, and he is reporting hot. Robert Simpson has joined us, 87 degrees Fahrenheit, near but not too near Detroit. Welcome aboard, sir. Who else did we miss here? Boy, test room 2003 is almost standard temperature and pressure. I appreciate that. So your channel's magnificent. You've been making some really cool videos. We showed in the thumbnail your ongoing grinder automation project, which I'd like to talk a little bit about today. And also we showed your electronic lead screw project, which I want to hear more about, because I've heard about it peripherally and I've heard about it from watching, some of your videos, but I've never seen one in person. Shaden HKW says, referring to Phil's report, he says, hot and a chance of bursting into flame by 2 p.m. Oh, hey, we have a new person here, Dan from Dublin, Ireland. Welcome, sir. 22 degrees Celsius and sunny. Nice to see you. Welcome aboard. I think you might be our first check-in from Ireland. So we will all raise a toast to you, sir. Welcome aboard. Okay. So, how did you get? So, what's your general background, and how'd you get started in this crazy world of machining?
Well, professionally, my background is software, but the thing about software is that it's completely intangible, and it's also never ever done, and so that I find. I mean, obviously it pays the bills. It's been good to me as a career.
Yeah.
But I wanted something tangible that I could do. And, sometimes I'm in the office when we used to be in the office working on software that's never done. There will always be another bug. There will always be another revision. And I look out and I see the guy mowing the lawn. And long for that kind of life sometimes. He's just running that mower back and forth, and when he's done, he can look back at it and he can see it and he can touch it and he can say, that's done. He has to do it again next week, but it's done. And so I've always, since I've been in this career, looking for, things that I can do. And I've always been drawn to things that are mechanical, electronic, technical. Took apart my mom's vacuum cleaner when I was 5. She walked in, found the Electrolux just spread out in pieces all over the floor. And she had no idea what to do. So she just said, James, put that back together now. And I did. I put it back together, and she used it for a couple more decades. And I've just always been interested in mechanical things. I had one of those little cars with you pull the string 3 times and then it runs, and it's kind of a clockwork with a idler wheel that pops down so you can change the angles, the wheels, it'll go out and run some pattern on the floor and come back. I opened it up. Of course, it's a clamshell with about 4 shafts and about 3 dozen gears in it, and pulled the string, and it exploded everywhere. I put that back together, but it was never the same. I didn't get the timing right. But I've just always been interested in that kind of stuff. And I got into electronics as a teenager. I had a guy who he came over at one point. He had a computer repair business, and he came over to fix my Commodore 64 that just ended up having a bad power supply capacitor failure. And he saw something that I'd built, and he was starting a little after school program to give kids access to computers and technology. And I got involved with that, and he was kind of a mentor to me, provided me some shop space to work. He bought electronic components for me, provided books and some mentorship. And I got into that and nearly went to school to study electronics. Fortunately, I kind of burned out on that and went into software instead, which was very fortunate because then I didn't have to take differential equations. But
I don't blame you.
I mean, yeah, that's how I got into software. And then, soon after that, I started, like I said, getting frustrated with the fact that everything I touched was intangible. So I bought a whole garage full of woodworking tools, did that for a while, and then bought my first 3D printer in 2016. Mm-hmm. Little 8-inch maker farm. Had all kinds of problems, immediately started, upgrading it, designing fixes for it, and designed and built a double extruder for it. Ended up selling a bunch of those as kits. And That's just kind of how it started. I started the YouTube channel in 2017, and it kind of came from a recognition that everything that I was able to do, the whole rep rap community, what I was finding in electronics forums on YouTube, machining videos. John Saunders was somebody that I watched a ton of early on. And in fact, several of the people here on the channel are watching Robin's channel, Tom Lipton, the whole cast at that time. And I recognized that I was only able to do what I did because all of those people had shared what they were doing.
Yeah.
And so I kind of started the YouTube channel just as a way to give back some of the things that I was doing, building on top of that. And it kind of just snowballed. I didn't really set out to become an influencer. I just sort of accidentally my way into it. I didn't set out to sell products. I just made cool things, put them on the internet, and people wanted them. And they just kept asking, where can I get that? Can I get that? I want to build the electronic lead screw. And I thought, okay, fine. I'll run a batch of 100 boards and we'll just see if people really want them. And I put them up for sale on eBay and they were gone in 4 hours.
That's amazing.
And it's like, okay, maybe I'll make some more of these.
Well, I can definitely resonate with the story of showing something on, in my case, it was Instagram, and 7 people said, "Are you selling those? Are you selling those? Are you selling those? Are you selling those?" And the answer, of course, the universal answer is, "Yes, I am." And now I'm going to figure out how to do it. So that's pretty cool. Now the electronic lead screw was a kit, and it went on a manual lathe. Is that correct?
Yeah. So the basic problem statement is you've got a manual lathe, and if you want to thread, you need a gearbox so that you can select the right pitch. So it locks the lead screw to the spindle at some ratio and allows you to cut the threads. But low-end hobby lathes don't come with gearboxes. They come with change gears. And change gears are a pain, especially on a lathe like the Grizzly Geo602 that I have. It's a little 10 by 22 lathe. As far as hobby lathes go, it's quite a capable machine, 350 pounds. It's a solid little machine. But the change gears are its Achilles heel, especially since there's no good way to shift back and forth between threading and feeding, because it's just a single lead screw. There's no feed gears like a lot of the little hobby lathes have. So if I want to set it up for threading, I've got to spend 20 minutes getting greasy doing that,
Yep.
adjusting the gear backlash, and now I don't have feeds for turning. And so it's just a frustrating experience to use that. And I was thinking, well, why couldn't I just put a stepper motor on the lead screw and an encoder on the spindle and then just replace the whole gearbox with software? And so that's what the electronic lead screw is. It's just a virtual gearbox with everything done real time in software. It uses a relatively fast DSP microcontroller to keep up. And it's, just generating the output pulses based on the input pulses. And so it's not a CNC controller. It doesn't know anything about path planning. It doesn't know anything about acceleration. It literally is just locking the lead screw to the spindle. So you don't have to worry about accelerating or anything, because your spindle starts from a standstill and it accelerates. And so it just tracks that. It's a relatively simple mechanical problem. The software is a little bit challenging, which is why, there aren't a lot of good hobby options out there. There are some, but they typically tend to be very speed limited because they're based on the 8-bit Arduino platforms, and they don't have the compute horsepower to keep up.
So first I
built this thing because I wanted it, because I couldn't afford a lathe that had a threading gearbox.
So you hit on something very interesting, which is you made something for you, and it turned out that other people wanted
Correct.
it also. And I think that's a very, very successful formula. I just want to recognize a couple of people that checked in. Machine New Zealand is here. Welcome aboard. He says it's 13 degrees and dry, but may rain today. And let's see, you have to go to work. You're putting your shoes on, probably. Yeah, Shaden HKW points out no gearbox noise either. But this was a stepper motor, correct? And was this your first?
It was.
Is this your first application of stepper motors?
That's a good question. I think it probably was. I mean, obviously, I had experience with RepRap based 3D printers, i3 clones, and so I was familiar with stepper motors and drivers from that. But I think this is the first, application that I designed from the ground up. I'm running a servo now. I wouldn't go back to a stepper. The noise is part of it, but also, you lose steps and all hell breaks loose. It's a mess.
We also just had a check-in from SCG, Function Model Bow, Big Scale, RC Models. That is a heck of a name, sir. 64 degrees or 17.9 science, 75% relative humidity in the middle of Germany. So welcome to the exact center of Germany. Grant Rickard checks in at 22 degrees, sunny in Reading, UK, and your Sundays are made by James Videos. Isn't that neat? So your Evil says, I was looking forward to hearing you say function models. I'm not going to do it again. I don't want to screw it up. So is that product still is still selling and people are still buying the kit, and where do they go to learn more? And no, this is hashtag not sponsored.
Well, I've got yeah, I didn't even think about that. I mean, there's a playlist on my channel with the whole development of it. And actually, I think that's one of the things that people really responded to.
Yeah.
Is that I started out from the very beginning, just saying, okay, here's what I'm trying to accomplish, had a whole pile of parts, talked about different microcontrollers, why I was choosing the one that I chose, why I was going with the parts that I did, what my thinking was, and what the sort of selection process was. Because, I mean, everybody has an opinion. Why didn't you use an ESP32? Why didn't you use an Arduino? I did it with an Arduino. It works just fine. And
I'm sorry.
So I really kind of went through that whole process.
This is on the internet that somebody has an opinion. I don't.
Yeah, I know, it's strange.
It's crazy.
Yeah, I spent a lot of hours arguing with them. Not really.
But so if somebody goes to your YouTube channel, they could find the information on.
Yep.
Or
if you just search Clough42 on eBay, that's where I sell through the eBay storefront because they have the international shipping and they handle all of that.
Mm-hmm.
Unless you're in the UK or South Africa for reasons we can talk about. But that's where the kits are. The software and everything's all out on a GitHub project, so you can go there. Just look me up on GitHub. You'll find the electronic lead screw project, and that'll have the pointers to everything you need as well.
That's pretty cool. So I did,
but I just built it. I mean, I built it for myself, like you said, and then people will say, "Well, can I get a board? Can I get that?" And you don't need it, right? It's a TI microcontroller. It's a dev board. It's a not for resale, probably not EMI certified, dev board that TI sells. And then you need to interface that 3.3 volt logic to the optical I/O on your stepper driver, and it has an input for a 5 volt open collector encoder. And so you can just kind of plug all this stuff together. And I used a little $2 off the shelf LED display board that you can buy anywhere in the world. And then you could just do this yourself. But if you want the PCB that I created that has the interface logic, has the level shifters and the LED drivers, it's like 6 transistors and a bunch of passives. It's not a big deal, but it's a lot easier if you just buy that. And I didn't set up the project in order to sell that. That was completely an afterthought. I just put it all out there so you could build it if you want. And the software is all open source. It's MIT licensed. You can do anything with it you want. But it turns out having a PCB is pretty convenient. And then it turned out that those LED display boards have a lot of quality issues, a lot of EMI issues, and a lot of ESD susceptibility issues. So I ended up designing my own version that is a couple dollars more expensive, but actually works reliably.
Yeah, I noticed
a lot of people want those too.
I noticed you were I watched your video on the test setup for those PC boards with your pogo pins and all that stuff. It's kind of funny because I have some history in the test business back when I was a young punk. Now I'm an old punk. And I noticed that you were using a dev board sandwiched with, your interface board. And I was particularly interested that you were using opto isolators, which I thought was pretty cool. And is that going out to the steppers? Are you using opto isolators to isolate your microprocessors from the steppers?
Yeah, so the dev board, no, it's not using opto isolators normally. But if any kind of stepper driver or servo controller that you buy off the shelf, they have opto isolators on the input. So the step and direction pins and the enable, you're really just driving an LED. So it's just an open collector output. I've got a MOSFET, an N-channel MOSFET that's driving that for the output. But for the test fixture, I wanted to get as close as possible to simulating the actual load that it'll be running on in practice. So if you've got a transistor that switches but can't carry current, for example, you would be able to detect that with the test fixture. So since that board's designed to be taking the 3.3 volt logic from the microcontroller and driving an LED and an optocoupler, I actually have that drive an optocoupler in the test fixture.
Yep.
Then the other side of that, I interface to some other digital inputs, just to put it under as close to the actual load it'll see in practice as I can.
Outstanding. Yeah, that was a good look into how you think as far as setting up the tests. And
right.
I thought it was great.
And I have no formal training in this. This is all autodidactic stuff. This is me going out and learning and picking the brains of very smart people.
So the correct terminology here, I know you're kind of new here, is I'm no expert. That's what you're supposed to say.
Okay.
Okay.
I'm no expert.
There we go. Okay. We just wanted to cover that.
Yeah. I just accidentally my way into all this.
Awesome. Let's see. Dave McIver from Auckland, New Zealand says it's overcast and 13 degrees science, and he says good morning from down under. John Thawley is here. He has a real question. How steep is the learning/setup curve for a non-electronics guy?
That is an excellent question. So, like I said, I accidentally my way into this. I'm not trying to create a product business, and I'm definitely not set up to provide technical support. So this is one of the reasons why the electronic lead screw is still an open source project and it's still a kit. So literally when I started, the fab that I was using to assemble the PC boards did not have, they did not support through-hole components. So the through-hole connectors are not on the board. They come in the kit and you have to solder those on yourself. And that is like the gatekeeper for this project. So if you can't put, 0.1 inch headers through a PCB and solder it on successfully, if you look at that and that terrifies you and you don't think you can do it, that'll probably keep you from building the electronic lead screw. And then that keeps me from having to support a lot of people who kind of bought this thing thinking it was a turnkey product and then come back for support.
So
I'm happy to help when I can, but I don't have the bandwidth to do that.
So is there no built product for this? They're all kits. Is that correct?
It's all kits. That's correct.
Okay.
The other thing that people ask me all the time is if they can get turnkey kits with all the right servos and the mechanical components. And the answer is I figured it out on my lathe, and there's no way I could guess which servo is going to have the right amount of torque and speed for your application.
Yeah, that's a tough one because there's a zillion lathes out there. Robert Simpson, welcome aboard, sir, says the banana plug adapter is cool too. And I sort of recall the banana plug adapter. Why don't you tell us about that?
Yeah, so I've got an electronic load, a Siglant electronic load, and it comes with screw studs on the front, and that's because the maximum current that unit can sink is probably more than you would want to put through a typical banana plug binding post. But most of what I do, it would be really convenient to have some banana jacks. So I just made an adapter. It's a 2 millimeter thick PCB with 2-ounce copper on both sides that you just slap over the binding post, screw it down, and then it's got 20-amp banana jacks in it.
I saw that.
And then 3D printed parts to shroud it, and it makes that load a lot more useful.
How do you like today's availability of PC boards?
I like it. It's controversial. There are a lot of people with opinions about it.
Yeah.
I just had a conversation thread with somebody who doesn't understand why I would order PCBs from a fab when you can etch them yourself.
I remember.
Yeah.
I remember those days.
I have a bottle of ferric chloride, but I don't want to do that. I like solder mask and I like fine pitch surface mount components.
I find the ferric chloride a little bitter. Sometimes I prefer some of the others, but I can understand. So
I seriously looked into getting one of those regenerating, etching baths but it's like having a fish tank. You got to take care of it, and I do it so infrequently that it's just not practical. It's the same thing with aluminum anodizing. I would love to have an anodizing line here. I don't want to store the acids. I don't want to deal with it. I don't want to deal with the disposal.
If you make go to the bottom of my street and you make a right turn and you drive 2.5 miles, you're at an anodizing plant, and it's wonderful. So, but we can come up with an idea in Fusion. Right, in Fusion 360, which is now called Autodesk Fusion. They dropped the 360 taxes, and you could make a schematic, make artwork, hit a button, and from the time you hit the button to the time the PC boards are in your hand is what, a week?
Something like that, yes.
Which is just amazing. That was a huge impediment to building some things years ago. So that's pretty neat.
Yeah, and it's pretty impressive, the software and the tools that are available. And I've mostly switched over to KiCad for that, or KiCad, depending on where you are and what your inclinations are. But yeah, and there's plugins for your favorite fab. I do most of my stuff through JLC PCB, but if you want to go through PCBWay, there are plugins. You just hit a button and it just drops a pile of files. You upload them and go.
So Evils says KiCad, the only right way to say it. So Evils, don't you have some relationship to that software that he didn't admit to until we got here? You could put it in the chat. I don't quite remember, but I believe Evils is a maintainer of software. Yeah, so Evil says, I kind of maintain the Nix package for KiCad. So...
Oh, okay.
Isn't it crazy who you're meeting in this place? So okay, let's talk a little bit about CAD software, because it's one of the things we promised to talk about, so we have to do it. Otherwise, people get angry. I thought about this yesterday. I was thinking about talking about this subject, and I realized, oh yeah, we're going to talk about SolidWorks, and then I realized, no, I go back to AutoCAD. When AutoCAD was text-based commands. And when SolidWorks came out, they were the new kids on the block, and they were going to do this newfangled way of doing CAD. And I remember that, and it was like, wow. And eventually, and of course, SolidWorks was sort of inexpensive or free for a long time, and then it became the thing, and we all started using SolidWorks, and AutoCAD, which is owned by Autodesk, became, in my mind, deprecated. It's like, oh yeah, we're not using that anymore. And then SolidWorks got bigger and bigger and bigger and bloated and huge, and all of a sudden along comes Fusion 360, and Fusion 360 is the new kids on the block. And I have now officially, and when I say officially, I mean within the last 2 months, I have gone off support for SolidWorks, and I was a SolidWorks seat for years, and now I'm 100% in Fusion, and perfectly happy. It's doing everything I needed to do. except for a couple of things, guys, but we'll talk about that another time. So a couple of weeks ago, I had an issue where I'm designing this box, this high power RF box for a customer, and I had to locate this connector on this box so that it was, parallel and up against the thing and in the right position. And I was pulling what little hair I had left out. And I got some help. In fact, John Saunders got me out of the hole. We got it figured out. But as we agreed to point out to the universe, it was the difference between SolidWorks think of mates, right, and fusion joints, which are completely different. And if you approach fusion joints with your previous knowledge of SolidWorks Mates as being sort of semi-equivalent, you end up losing your mind. So,
yes,
you had a problem just recently, right? Same issue. And what's the way out for teaching folks how to think about fusion joints?
Well, I'll say I'm no expert. I will also say that I got into fusion watching John Saunders videos back when he was doing a lot of fusion stuff, just showing how to do things. And he's focused primarily on subtractive machining. I was focused at the time primarily on 3D printing, but the basic tools are the same. I came from SolidWorks, but again, I'm no expert. I didn't come into that from professional use. After I got my 3D printer, I'm looking around for software I can use to design things. And you see something like OpenSCAD and think, wow, this is really neat. And then you get into it and realize what it really is. And okay, I totally understand why people like it, but it wasn't what I was looking for.
Yep.
And I had access to a license server that had some SolidWorks licenses that I could use after hours. And I played around with it and learned how to do everything in SolidWorks, and then only switched over to Fusion when I started doing things that were, potentially going to generate revenue for me. And I needed to, have fully licensed software to feel good about that I was paying for. And so I got into Fusion and made that switch. And that jump from mates to joints was something that was a real brain bender. The other thing that really tripped me up was the lack of configurations.
Right.
Now, Fusion has configurations now, but they're also a completely different animal. So to your question about mates versus joints, I think the simple explanation, which, you Google it and the AI will tell you this, is it's a difference between a mate constraining 1 degree of freedom. So you use multiple mates typically to fully constrain something in your model. But the joints in Fusion are intended to use a single joint to fully constrain and define the motion of the parts. So where in SolidWorks, if I wanted to put a pulley on a shaft, I would make it concentric to the shaft, and I would make it coplanar with something, and I would keep adding constraints in the form of mates until I got it to the point where the motion was what I wanted. Where in Fusion, what you would do is select the right joint origins and define one joint that says, okay, it's in this position and it can rotate, or it's in this position and it can rotate and slide, and here are the limits. And it was particularly confusing when I was initially learning it, because most of the YouTube videos that showed how to do this were not from an engineering perspective, they were from a design perspective. And so people in the videos were using the as-built joints. So I remember there was one video where there was a lamp that had a switch, and they just modeled the whole thing, and then they sort of separated the switch and said, okay, this is an as-built joint, it can move like this. And that just that broke my brain, because that is very much not an engineering way to think.
So when I solved the problem I was working on a couple of weeks ago through John's help, I learned about what you just mentioned very quickly, joint origins and placing a joint origin. And that was sort of half of my battle, was learning that, oh, you put a joint origin somewhere that you want to match the two things up. So that was the first thing I had to learn, is that you can place a joint origin somewhere. And then the other was the concept of, if you have a structure that has no motion associated with it, you don't really need anything fancier than a rigid joint. It's like, in my case, it was joint origin, put the thing here, they snap in the right place finally, after learning how to put a joint origin, and then I was done. Yeah, but what about all these, dozen choices of slider and rotator cuff and, all these different things. And I realized, I don't need that, because I'm not making a machine. So, but if you're making a machine, that's when you have to start getting good at those things. Am I reading that correctly?
Yeah, I think that's right. The other thing that I often use joints for is if I'm trying to position something in free space with relative to something else, like if I'm trying to make a Gridfinity tray to hold a tool. I have my model of the tool, and I need to position that somewhere in the volume of that tray so that I can use that as a tool to cut out a cavity. I'm hitting my microphone. And the way I will typically do that is, maybe the end of the tool is round. I can pop a joint origin right on that. The end of the tray is rectangular. I can pop a joint origin right in the center of that, and use the offsets to move that around until it's in the position that I want. And those dimensions mean nothing. They're just a handy way to lock it into position in 3D space, and to go back and adjust it later if I need to.
Yeah. Sorry, I just think I got to turn off this B1. No, we're okay. So what do you recommend for somebody who is playing around in Fusion and they want to start learning about Fusion joints? This is somebody who doesn't know any SolidWorks. My recommendation.
So there are a couple of YouTube channels. My recommendation would have been go watch all of John Saunders' old videos on Fusion, but I don't know if he talked very much about joints specifically.
Yeah.
So I think he was more concerned about defining single objects and then machining them out of by subtracting metal.
Yep.
There are a couple of channels. One that I've been looking at a lot recently is Product Design Online, and there's just a fantastic set of kind of tutorials and lessons out there that I thought were really good.
I'm making notes.
And so I would put that high on the list. Yeah.
Now, for somebody who...
And there are several that are very much like a Fusion from scratch, or 30 days to learn Fusion kind of stuff. I don't tend to think that way. I don't tend to go out and say, okay, I've got a list of things I need to learn, and I'm going to learn them and memorize them all. I am very much a hands-on learner. I need to do a thing. I've got some skill set that can get me to a certain point in my project, and I need to know one more thing, and I'll go out and figure that out and then do that. And then my next project, I'll need to learn a couple more things, because the project is, my reach is just exceeding my grasp, and I need to learn a couple more things to do that. And that's how I tend to approach it. So these really short 2-minute videos that show you just how to get something done are really handy for that. But you run the risk, like with the switch from SolidWorks to Fusion, you run the risk of just approaching the problem in the wrong way because you don't understand how you're intended to think about it when you're using this tool. So some of that fundamental, people who really understand that and start from the beginning, some of that can save you a lot of pain.
They really ended up solving the problems totally differently than SolidWorks. I find it very interesting that they ended up in such a different place, which is why I think the recommendation for a SolidWorks user switching over to Fusion is a lobotomy. I think that's the first step. Forget everything you know about Mates, because it ain't going to work.
Yeah.
And you mentioned configuration. So I had another project, a fun project. We've been making some Apple AirTag holders, affectionately known as the Damn Keys and the Damn T, which is used, to find your damn T, like that, and also find your damn keys. So I wanted one model, one Fusion file, and have two configurations, one for damn keys and one for damn T. And that was my impetus for learning the relatively recent addition, I think, to Fusion of configurations. And I think I got 70% of the way there as far as understanding it. I think there's more to go, but I think it's all in there.
Yeah, for sure. It is, if you think about the problem in the right way. And this is another case where if you came from SolidWorks, your brain is going to hurt. The fundamental thing that, at least to me, that I see in the difference is that in SolidWorks, configurations are in a tree structure. So you can come down to a particular point in your timeline where, again, I'm using Fusion Fusion terminology here. It's linear. So you've taken a bunch of parametric modeling steps to get to the point where you are, and in SolidWorks, at least the way I used it, there were basically two things you could do with different configurations. You could change parameters, like you could change dimensions on things, and you could create a tree where down one fork of that tree, you add one set of operations or one set of primitives to that, and down another fork of the tree, you have a different set. Where in SolidWorks or in Fusion, it's not like that. It's linear, and you can turn individual operations in the timeline on or off, individual features on or off. But if you really need to diverge and kind of go in different directions, it can be a real mess.
Yeah. And there are cases where
I know I was,
yeah, there are cases where you simply can't. The logical thing would be to again, in software world you'd call it fork,
right,
a different thing, but there's no real mechanism for that.
Well, there kind of is. What you can do is you can group features on the timeline into groups. They're little collapsible groups, and then you can suppress and unsuppress those entire groups. And so if at the end of your timeline, you just have 2 or 3 different groups and each configuration only has one of those turned on, then it's kind of a tree, but you can't view it as a tree.
Yeah. Interesting. Well, hopefully it's everything we need is there. One thing I have noticed about Fusion, and see if you agree with this, is that their responsiveness to adding or improving or fixing things is pretty good. Whereas I think in SolidWorks, it's slower and bigger and logier. Would you agree with that?
I think that's true. Now, you do have to add the caveat that as long as what you need in Fusion is something that a lot of people need, and 2 is on their vintage chart. It's on their kind of view of the world and where it needs to go.
Yeah.
So yeah, if a lot of people are wanting some feature and it's actually on the roadmap, then yeah, they can be very responsive. But I know configurations just took forever. And they've also launched a few features and then taken them back. They put something out there for a while and then decided, yeah, this is not the way we want to go. This isn't working, or the approach we're taking ended up not meeting people's needs. And they'll actually pull features back out, which I think is a really important thing to do as a software organization, to be able to do that. Because you look where Microsoft's gotten themselves by never taking anything away and supporting legacy forever. Yes. There are very good business reasons to do that. But this is how you end up having NTLM security issues on your network, because you're trying to run some protocol from 30 years ago that was just never even designed to withstand the kind of threat profiles that we have today.
But those sort of network problems are rare. They hardly ever happen.
Yeah, no. Most people have no idea have never and will never see an issue with that.
Recent events notwithstanding. Which we're not going there. It's okay.
Okay.
Welcome to K-Bonk, who just checked in from the Philadelphia. Welcome. He says 89 degrees and sunny in the Philadelphia. What's your guys' take on Fusion 360 simulations versus SolidWorks simulations? This is from Steve Tessier. Is it Tessier? I can't. The type's too small. So Steve, I think that the fact that I've used both actually, and I remember having to go to a buddy of mine and say, "Hey, do you have a license for this simulation thing? Because I want to run this simulation thing," and he'd run it for me, and then he'd send me back the results. Whereas in Fusion, you kind of have access to all the simulation stuff, and you only pay extra shekels if you want to use their cloud. I haven't done an awful lot of simulations, but I believe that's how it works.
I haven't either. And there was a time when, that was really one of the big differentiators for Fusion, is that everything was bundled and everything was included. If you had Fusion, you had everything. You had the rendering system, you had the flow dynamics simulations, you had the finite element analysis, and you could just run all of that stuff. Now, I believe they have started moving some of that behind further licensing. Like, I know the cam stuff, if you want to do simultaneous 5-axis, that's an additional license. So some of that stuff they've done. And then of course for the hobbyist version, they have crippled a lot. I used the hobbyist version for a while, and then when I started actually doing things that would make some money, I switched over to their startup license.
Yep.
Which was free for as long as your business stayed under 100K revenue a year. And I used that for a number of years. And then they changed that license. So now you can only do that for 3 years, even if you're not making money.
Right.
And so when they changed that, I just paid up. And I've been paying for a commercial license, and I'm generally pretty happy with that.
I remember when I first learned about Fusion, and I remember sitting in my comfy chair downstairs with my laptop, and I'm messing around with Fusion, and I did a few things, and I'm a paid SolidWorks seat, and I'm like, shut up and take my money. I remember it was $300, yes. And I could not give them $300 fast enough, and I think it's still a good deal. But I also have seen, not really been impacted by the clawback of some of the features, but you could do a simple stress analysis, stress simulation still with the existing simple license, and it's pretty stinking neat. And they do have their cloud if you want to use their computer.
Well, and that's if you look at the objections. What are the objections that people have to Fusion? One is the way they did the clawback of those features when they first came out and said, "Okay, yeah, we're gonna pull this back." The way they did it really angered a lot of people, and they pulled back pretty deep. They've let some of the stuff go again, but they were things like you just couldn't export your models. Like, you couldn't export in a step format. You couldn't export anything out of their cloud storage, so you were trapped in their system completely. You couldn't even export a drawing to PDF. There were lots of things that they did that some of those they've backed off from now. Like, now I think you can export, but drawings are limited to a single sheet. They're kind of things that would be okay. They've got this weird thing where you can only have 10 active documents at once. But I honestly don't know how bad it is because I haven't lived in that world recently.
Right.
So that's something that angered a lot of people. There was another thing I was thinking about that I haven't. I think it'll come to me in a
minute. But for right, is it $350, $400 a year now? It went up a little bit.
It's almost 500 now. I think it's 465 or something.
Yeah, I mean, even for a small business or a serious hobbyist, that's not a ton of money, and they've earned it. One thing I think they've really not quite caught up to SolidWorks on, and this won't come as a surprise, is drawings. I think the drawings are still not quite there yet.
I never did those in SolidWorks, so I don't know. The other issue that people have with it is the cloud storage. The fact that it's your documents are on their servers. With SolidWorks, it's pretty easy to store your stuff locally, check it into GitHub, and then you own it. Well,
right.
You own it. But if you don't have a license for the software, you can't do anything with those files. I got piles of SolidWorks part files that I can't do anything with. So to me, it's functionally the same, unless you're running a pirated version of SolidWorks and you got your license. Then I guess you could keep your stuff forever. But
of course now Fusion, you can upload a solid part, for example, to Fusion, and it will go into their cloud.
I need to do that. I haven't.
So it absolutely can. So you go into Fusion, on the left side, it says up. There's a button that says upload.
Yep.
You just upload a solid part. Actually, you could upload an assembly. You could take a SolidWorks assembly and hand it to Fusion. It goes up to their cloud, and their computer crunches away on it, and then it's in your account. So check it out.
I mean, there's going to be limitations on that, right? So it's always a question of what features did you use and is everything supported? But yeah.
Well, one of the reasons I kept SolidWorks alive, I mean, it's still alive. I still have a license for it, but I'm off support, is that my clients, the probability was that they were using SolidWorks. So they would heave me their product design, and it was going to be a SolidWorks thing, and then I had to use SolidWorks. Well, now it's gone on long enough that I've tested it long enough. It's like, no, actually, I can get away with using, bring it into Fusion if I have to. And that's been pretty good.
Do you get the full parametric timeline from that, or are you just getting like a solid model import?
You're just getting the solid. So you're not getting the full timeline. We had a couple of questions come in. K-Bonk says SolidWorks is terrible with legacy issues. K-Bonk asks, can you run Fusion off the cloud yet? I think you mean like open a browser and run Fusion. I don't think so. I don't think you can do that.
No, it downloads, but you don't, at the risk of getting into a bunch of technical detail, you're not installing it on your local machine like you would as an administrator and dumping a bunch of stuff into program files. It actually is going into your local user app data cache and running from there. And so Microsoft had a bunch of technology. They called it one-click with .NET applications at one point, where it's kind of a web application, but it has code that executes locally, but you're downloading that and caching it on a per-user basis. And they're kind of somewhere in that intermediate world.
Okay. Remember that part where you said you didn't want to get into the software? My brain exploded when you said that. But there are people out there that did understand you. Let's see. Greg Koenig says...
I'm sure there are in this group, yeah.
Yeah, a couple. Greg says, in industry, the biggest thing holding back Fusion is no ITAR. Yes. I get asked about it from customers at least once a week. I work for a machine tool builder / dealer. Right. So right now, Fusion cannot live not connected to the internet, not connected to their cloud for various functions. And that makes ITAR people unhappy. So for those of you that might not know, ITAR stands for something, which I don't remember, but it basically means if you're designing nuclear weapons...
International Traffic in Arms.
There we go. Thank you very much. If you're designing nuclear weapons, you can't be modeling your stuff on something that touches the cloud. So SolidWorks, for example, is able to run sitting on a computer locked in a room somewhere, whereas Fusion cannot. Now, Inventor, which is their version of a thing that runs on a computer that doesn't have to touch the internet, I believe can be ITAR compatible, but not sure. New York.
I'm only familiar with it because of the software world and because of cryptography limitations.
Right. New York Machinist says you can skirt cloud storage by exporting as an F3D and saving locally, unlimited with a hobby license, no cloud. So there you go. If you have, you said there was like a 25 document limit for
10, I think, right?
or something.
Sure.
But he's saying you could export it locally as an F3D file. I don't know what the limitations are.
Well, I mean, that allows you to store it locally, but then you have to upload it back to the cloud if you want to edit it.
Yeah. So I think
you're still using it in the cloud. You're just archiving.
Yeah. A lot more shuffling around. Yes, Robin, we will do a surface grinder update as soon as we finish squeezing this lemon. Robin says it's less than the $1,372 support you were paying for SolidWorks. Absolutely. That's why I unfortunately let go of SolidWorks. And I was a pretty early adopter, and a buddy of mine in Texas calls me up one day. His company sold, I guess you call it a VAR, value added reseller. He was a value added reseller for SolidWorks, and I get this phone call one day, and it's Dave, and he says, "Yeah, hey Spence, listen, you need to buy SolidWorks right now." I'm like, "I do?" So it was a screaming deal, and I did, and it was from that point on to a couple of weeks ago that I was a licensee. Greg Koenig says, just for perspective, NX 3-axis CAD CAM is $11,000 a year. Esprit is $12,000 a year. I could tell you some numbers about antenna modeling software that will make your socks roll up and down, but I'm not going to. Do you guys get the problem of SolidWorks randomly crashing for no good reason? No, there's always a good reason. I don't. I haven't really had a crash in SolidWorks for quite a while. Not SolidWorks, in Fusion. Oh, no, you're talking about SolidWorks. No, I've not had random crashes recently. Sorry, sir.
I've crashed Fusion in the last week.
Have you now? Well, you're keeping up with things. So I think we wrung out the beast of the SolidWorks to Fusion thing. It's still an issue, and we're all fighting it. But I think the punchline, tell me if you disagree, is that Fusion does 99.999% of what we need it to do. Do you agree with that?
I might dispute the number of decimal places, but it does everything I need.
Okay, we'll take that under advisement. We'll take that into committee. Okay. Surface grinder project. You have had this magnificent project where you are taking a brand new Acer. Is it Acer? What's the brand of your surface grinder?
Acra.
That's it. An Acra surface grinder, and you are taking it from being blissfully ignorant to absurdly intelligent. Maybe even artificially intelligent, we might say. How's it going?
If I had more time, it would be done. It's like every other project that I have. So I've made a bunch of progress on it. Most of what I've done, you've seen on the YouTube channel. Got the mechanical linkages, figured out how to get the servos to it, actually figured out how to get the servos to move it, figuring out how to get the servos to deal with the inertia, the limit switches. There's a lot of kind of unknowns, and I've just kind of been working through those, finding the problems, addressing the problems, upgrading to a different kind of motor that has other features that I need. And I've gotten to the point where I've got a control panel put together, like physically built, got the controls figured out. I've got a whole notebook full of sketches of what I actually plan to do with it, kind of what I think the user interface is going to be like. Got some sketches of how I think the control loops are going to need to occur in the software. I have not actually gotten to the point of writing the software, and it's just been time availability.
Yeah, but software is
had a bunch of downtime.
Writing software is trivial. I don't understand. It doesn't take long.
That's true. Writing good software that accomplishes what you want, doesn't crash the machine, doesn't hurt the operator, and that you can actually maintain in the long term takes a little bit more planning.
Now you're over specifying it.
And that may be true, right? I mean, I've programmed the thing. I've had the grinder running back and forth, and the next step would be to get the control loop set up for the encoder, so I can drive it around manually with the MPG and actually change the resolutions and kind of get that working and validate that. Robin has very kindly provided some feedback on the design for the UI. He has some points that I think are going to affect me, and I think he has some points that I think would really irritate him, but are not exactly what I'm trying to accomplish. So I'm going to make my own decisions and move forward and see what happens. And what I may learn out of this is, oh yeah, Robin warned me about that. That's a really big problem, and that irritates me, and I'm going to have to take a few steps back.
That does sometimes happen, by the way.
I appreciate all of the input that people have given me, and Robin, we've talked to him on the phone a couple of times about it. And yes, I've taken some of his advice, and I'm ignoring some of it, perhaps at my own peril. But I kind of have an idea of where I'm going with it, but I also realize I have a lot to learn. I have a lot to learn. I think I know how the mechanical system is going to react, but I'm going to find out. Like, I did not anticipate the servo control loop issues on the table. I didn't think about the springiness in the system and how the servo control loop was going to deal with that. And that's a big issue. Another issue that I'm worried about is this is a cable-driven system. Right. So it's a vinyl-coated wire rope wrapped around a spool. It's not attached to that spool. So it's not like the flat spring steel tape. It's not a cog belt drive.
Right.
So I think I can't count on that cable staying put on the spool. I think in practice, it's likely to stay put well enough, but I can't count on that as an actual constraint. And so I've been planning to run back and forth between limit switches. I've also been thinking it really would be a lot easier just to drive it to where I want, say, set that as the extent and just have it move there under software, because then I have a lot more control about decelerating to that point rather than hitting the switch and then going, oh my goodness, do I have time to stop? I think at this point I'm going to try setting the constraints in software and then using the limit switches as a backup. And I've also thought about converting it to hydraulic. I've thought about converting it to a ball screw drive. I've thought about converting it to a belt drive. But those all sound hard, sound like a lot of work.
So
I'll try the software solution first.
Point of interest, the Okamoto has a not exciting encoder on the x-axis. It's a hydraulic table, and it has a 5/10,000ths good encoder. And you do that. You move the table somewhere, you hit the button. You move it somewhere else, you hit the button, and it knows where it is within the 5 or 10,000ths. Robin has some input. So why don't we listen to Robin?
I'm sure he does. Yeah.
So Robin, we're bringing you in audio only. Go ahead. You have to, we'll see what happens here.
Got me?
Yeah, we got you.
Yeah, we can hear you.
Pennsylvania, you're on the air. Hello.
The cable drive on my Herring, before I automated it, I got rid of the nylon completely by doing a Gothic arch groove that cradled the cable so that the cable was kind of supported and had kind of a V-belt effect where there's a little bit of a wedging action. That never moved, and the cable wore perfectly. It stayed. I mean, cables lasted a long time. And
was that a spiral groove on the spool?
Yeah, spiral groove. Yep. And then the post points are such that when the table gets all the way to the end, at one end, that post is lined up with the groove that the cable is at. So basically, the cable is coming off and happy at either end. When I did my grinder modification, I switched over to a timing belt, and then I have a setup that isolates the cable tensions from possibly bowing the table. So it's an actual bar that has a kind of like the equivalent of the bar that's in a guitar neck that resists the tension of the strings on, opposite the fretboard.
Hmm.
I have that version of that underneath the table, and the table just has a single pin that engages that to isolate those things. But
Okay.
I'm seeing timing pulley rumble that I don't like. So I'm thinking about going back to the pulley. One
Okay.
thing
Yeah,
is
and that's what I was thinking about. Is I was worried that I would see the belt teeth in the
right.
finish.
Now, one thing that I'm planning to do there is to actually make um, the pulley the equivalent of a expanding lap, such that you get the pitch diameter, the effective pitch diameter of the pulley to be very close, but smaller than it needs to be. And then you can adjust the expanding lap to get it so that the motion per step, if you want to put it that way, is extremely close. Now you go full travel and say, okay, I need to tweak it, and you mechanically adjust that diameter till that's good.
Hmm.
Then put a prox sensor that is in the center of the table, and every swipe of the table, it resets the X counter. And
Okay.
that way you can't, even if it creeps, it doesn't care because it's resetting. Now, I probably would make it do it every, 20 or 50 strokes or something, because it's not moving fast. And I don't think it's moving at all, actually. That Gothic arch groove is the key. It's where it's kind of a wedging action, but still kind of a circular. Think of the Gothic arch of a linear rail, that shape for the
Right.
cable. And then that eliminates that. You can tweak it, and then the electronic stops, like Spencer mentioned. My grinder's like that. You crank it over to where you want, hit the left button, crank it the other. That is so sweet. That and
Yeah.
not that movable table stops is there's anything wrong with that, but so that's something I will eventually approach on the grinder.
Uh,
You just said something that it hadn't occurred to me. It had not occurred to me to put a prox sensor in the middle. I had been thinking about having it on the end, and when I get to the end, resetting, or if I over travel and hit it, resetting. I had not thought through having it go by that sensor on every stroke and just resetting the counter. There's no reason not to do that.
I agree.
and there was a question in the chat. Why not use inductive or capacitive sensors, maybe Hall sensors?
You could use any sensor you want as long as it's consistent. And you could even make it so it only triggers on one side, so you don't have issues with it
Right.
being, different because of the on-off change from direction.
And just as a
Yeah, well, the software knows which direction you're going, so that can be done.
and as a probability thing, you're gonna hit that center one more often than you'd hit the ends.
Right. Well, and in the end, it doesn't matter, right? Even if you're off by 10 thou on every stroke, and you got 10 thou of jitter, 10 thou is not going to matter on the end of
Right.
the x-axis stroke on a grinder.
And that's why when I looked under the skirts of the Okamoto and I saw this little, small little encoder, and I'm like, oh, they
Now,
did.
is that an encoder with a wire on a spool, or how do they do that?
You're asking me a hard question. I don't know.
Okay.
I could find out. But when you dig into the control, you go to the Fanuc side and you bring up X, Y, and Z, and you see Y, 5 decimal places, Z, 5 decimal places. Then you see X like jittering, sitting there jittering, and you say, oh, okay, they didn't spend money where they didn't need to spend money. I could probably take a picture of that for you later. We'll get you the make and model of that thing, because it's under.
I have a different answer for you now on the progress on the grinder project, and I thought there's enough engineers and machinists here on the channel listening that I think some of you would appreciate this. I find myself procrastinating and having trouble making progress on a project, and I almost always realize in retrospect, I don't realize it at the time, but I realize in retrospect that what's really going on is I'm blocked because I haven't come up with the idea I need to move forward. Like I know what needs to be done, but I don't have a clear enough picture in my head of how to do it, or I'm wrestling with some problem or some decision. And then at some point I have this epiphany, or I'm rolling around the idea. It's like, I have an idea. I know how I can do that. And then it falls into place. And then I can make, um, all the progress I would have made over the last year in an afternoon. And that is a very, very common experience for me.
Well, are you beating it around with other people like us, or are you grinding it in your head?
Sometimes, but a lot of it's just in my head. Now, beating around with other people, like that suggestion from Robin today about putting the sensor in the middle and just resetting. That gives me a path forward around several things that I've been worried about. I mean, ultimately, the biggest thing I'm worried about is crashing this thing and breaking something expensive or hurting someone. And so that's kind of a lot of my thought process. And I think putting that sensor in the middle and just adjusting for the creep and doing everything digitally, I think that solves a lot of problems for me.
And I could tell you, your stress level will change after the first crash. It gets a lot easier. Sorry.
I thought you were going to say it the other way around. Honestly, that's one of the things I love about 3D printing versus CNC machining. So I've done CNC conversions, and when things crash, I love carbide tools because they just go away. They don't bend and break stuff.
Yeah. Well,
they're expensive, but they just go away. And then you have to retram the spindle, but you don't destroy anything.
Well, in some
that's what I love about 3D printing. Even when they crash, you just hit the button and go.
In some circles, spindles just go away, but I'm not going to talk about that right now. We have a couple of questions. Greg says, this is sort of a little bit of a detour. He says, I'm looking at an Okamoto, and it's interesting that the 8x18 form grinder is, quote, ball screw, close quote, driven. Greg, there were two versions of that. That's my grinder, by the way, the ACC 818. There's two versions, or I should say it a different way. The ball screw on the table is an option. So normally it's a hydraulic table, and then you can add the option of a ball screw on the table. So it's not always a ball screw. And by the way, that's a $15,000 uptick if you want the ball screw on the x-axis. Tucker, with his tongue firmly in cheek, says, I don't like making mistakes. Hard to make progress when you might screw up. Listen, buddy, if you're not making mistakes, you're not doing anything. Dale says
it's hard to make projects. It's hard to make progress when you're afraid of screwing up.
That's true. Dale says, I need pressure like a deadline to get my ass in gear. We all know that feeling. And it also depends which gear. Moving on. So, Robin, do you have anything else that you want to insert into the grinder conversation here?
I could answer Evil's question of, did you have slippage before the Gothic arch groove? I think probably it was slipping minutely, but that's not the reason for the Gothic arch. When you wrap a cable around the straight cylinder, which I did for a while, the cable ends up fatiguing on the inside where all the pressure's on one set of fibers that happen to be wrapping on the bundle. And by doing the Gothic arch, where the radius of of curvature, and basically that most Gothic arches, just for reference, the arc diameter for the Gothic arch is about 52 to 54% of the ball radius. So it's very close to fitting. So that gives a very good support so that the cable is being supported full circle and it doesn't end up fatiguing. So the last one I put on there, I think I ran for like 3 years before it finally gave up. And yeah, that's very important. One thing that I want to implement on to get rid of the resolution selection on the hand wheels is to, and now keep in mind, on my end, I'm talking about using PLC commands to do this, which is super easy. But Clough being a software developer, most of the stuff's probably easy for him in code. But the premise is, look at the frequency of the hand wheel, and when it stays at a certain level for a certain amount of time, you change the ratio on the fly so that it's somewhat progressive. So that if you're cranking, you say, oh, I want to crank all the way across instead of using rapid. You start cranking and you're cranking it as fast as it's comfortable to crank, and it says, oh, wait a minute, this guy wants to go faster, and it slowly ramps up and comes up to speed, and then slows down accordingly. So, and I don't even use the calibrated amount per click. It's really purely just for how sensitive I want the handle to be, because I'm using a pseudo digital where I'm displaying the motor position, and that's my digital readout, and that works awesome. I don't care about backlash or anything. It's purely functional. So I don't even care about that. I just look at my display and click, click, click. I'm not, and I took the detents out of the hand wheels because that's I don't like them. So they're just free spinning hand wheels, and I'm going to just add that velocity sensitive gear ratio so that it's a lot friendlier, and that's easy to implement with the PLC. I think the PLC I'm using, the update rates like I don't know, every 5 milliseconds or something, like 4 milliseconds. It's very fast. So it's pretty transparent.
Cool.
That's the last thing.
I don't think it's the last thing, but
Cool.
There'll be more things. Well, James, we could do this for another 3 hours, and I'd be getting hate mail for the next 6 months.
I probably could.
Yeah.
Yeah.
So, anything you want to leave us with? Account numbers, anything?
Yeah, I mean, not in particular. I've enjoyed the conversation, and like I said, you just invited me to the Discord so that we could do this, and I've been hanging around for the last week and a half, and there's a lot of cool people here, a lot of brains to pick. I think I'll be taking advantage of this resource.
Excellent. Well, we are very happy to have you, and this has been a lot of fun. And I'm sure that everybody will get a kick out of subscribing to your YouTube channel, which is Clough42. And if you guys need anything flat, just head over there to that. No, it's over there. PFGstones.com. Oh, by the way, we had a very interesting IT problem show up this week. I have all of these little .gg pointers, like PFG.gg. And some browsers were trying to do it they were insisting to make a secure connection, and it was breaking something, and people were not getting through. So I just want everybody to know everything still works. Just go to do HTTP PFG.gg, and that works. And I'm going to be making some changes behind the curtains to make that not go wrong anymore.
Yeah. HTTP is a pretty bad idea these days, and the browsers are attempting to force everybody down that road.
Yeah, so it broke something associated with the free forwarding that I was getting on Hover. Hover said you can get a domain name on Hover, you could forward it to another domain, and that was all glorious, right up until your browser insists on it being an SSL connection, and then it gets to Hover, and it says, no, you didn't pay a nickel. You don't get the SSL certificate. So I'm working on it right now. But if anybody's having that issue, just hang in there. No, that was a different problem, Stephen, with the gallery, I think. But we won't dwell on that. So, James, thanks for being here. Looking forward to following your projects and helping where we can. And there's lots more to talk about in the world of 3D printing, which we didn't get to today. Would you be willing to come back?
Oh, yeah. Sure. Yeah, we could do it again.
Okay, then we didn't hurt you too bad. So you have an awesome day. And everybody, thanks for being here. Don't forget to, I know you're going to hear it again, like, subscribe, comment. sign your securities over to. No, don't do that. And we'll see you guys next Sunday, all things being equal, for another PFG Live. James, thanks a lot. We'll talk to you soon.
Thank you.
I'm looking for a button. Oh, I found my button.